Okay, so picture this, finding fresh, totally drinkable water underneath the salty ocean. I mean, it sounds completely impossible, right? A total contradiction. But what if I told you that not only does it exist, but there might be enough of it to supply all of humanity for a century? Let's dive in. You know, this whole idea isn't even new. It actually goes way back, more than 2,000 years, to a Roman geographer. He wrote about people off the coast of Syria who would do something that sounds crazy. They'd row out, lower a tube into a specific spot in the sea, and the water they brought up was perfectly fresh. For centuries, people just wrote it off as a myth.
And yeah, that's the big question, right? How could you possibly pull fresh water out of the middle of the salty sea? I mean, it just seems to defy all logic. But as it turns out, those Romans were really onto something.
All right, so to solve this ancient mystery, we're going to have to jump forward a couple thousand years, where modern science accidentally proved what those ancient sailors already knew.
And you know, like so many amazing discoveries, this one was a total accident. It's the 1970s, and some scientists are drilling for sediment samples under the seafloor. They were totally expecting to find, salty water. But instead, they pulled up samples that were weirdly fresh. Turns out that old Roman story wasn't a myth after all.
Okay, so before we go any further, to really get what fresh means in this context, we got to talk about something called salinity. It's basically just a way to measure how much salt is dissolved in water, and it's usually measured in parts per thousand, or ppt.
And this chart here really puts it all into perspective. So your typical seawater, that's sitting around 35 parts per thousand. Those samples from the 70s, they came in at less than 3 ppt. Now, that's still what scientists call brackish, but look at that, it's a massive difference. For water to be officially fresh, it's got to be under 1 ppt. And what we drink is even less salty than that.
So where is all this water hiding? Well, it's not like it's just in some big bubble or an underwater lake. It's held inside something called an aquifer, which is just a layer of rock or sand that can hold water, and it's under the seafloor. And here's the crucial part, it's often trapped there, sealed off from the salty ocean above by something dense, like a layer of clay.
Okay, so we know these things exist. The obvious next question was, just how much water are we really talking about here? And how could you possibly map something that's buried deep under the ocean floor?
Well, the big breakthrough came when scientists got really clever and repurposed some existing tech. They figured out they could actually use the same kind of technology that the oil and gas industry uses to find deposits offshore.
And the way it works is pretty brilliant, actually. They tow this special antenna behind a ship, and it sends an electromagnetic field down into the seafloor. And here's the trick. Salt water is a great conductor of electricity, so it has low resistance. Freshwater, not so much. It has high resistance. So by measuring that resistance, they can basically see where the fresh water is hiding. Super clever.
And what they've found, well, it was absolutely staggering. Back in 2019, they surveyed that same area off the U.S. East Coast and discovered that all those little pockets of fresh water they'd found before were actually connected. They're all part of one single, massive aquifer that holds at least 2,800 cubic kilometers of water.
Now, to give you some perspective on just how huge that is, this one underwater aquifer is nearly 3/4 the size of the famous Ogallala Aquifer. That's the biggest one on the entire North American continent.
But get this, that's just in one spot. As scientists started looking at coastlines all over the globe, the estimates just kept getting bigger. The grand total of fresh water they think is hidden in these offshore aquifers is now around 1 million cubic kilometers.
1 million cubic kilometers. I mean, just try to wrap your head around that number. It's truly mind-bending. That's enough water to cover every single one of our planet's current water needs for a full 100 years. It's like a whole hidden world of fresh water sitting right there under the ocean.
So naturally, this leads to the next big question. I mean, how on earth did all this fresh water get trapped under the ocean to begin with?
Well, scientists have a couple of main theories. Is this stuff being refilled somehow, or is it what they call fossil water? Basically a one-time gift from a very, very different past.
Okay, so the first idea is that it might get recharged by rain and snow that falls on land nearby. That water seeps into the ground and flows out under the sea, which would mean it's potentially a renewable resource. That'd be great. But the second theory, and this one is way more dramatic, is that this water is ancient, a remnant from the last ice age, which would make it a one-and-done, non-renewable resource.
Yeah, This Ice Age idea, it paints an absolutely incredible picture. Think about it. 20,000 years ago, you've got these massive glaciers locking up tons of water. So sea levels were about 125 meters lower than they are now. What's now the seafloor was actually dry land, and so these aquifers just filled up with fresh rainwater. And then, as the glaciers melted and the oceans rose back up, thick layers of mud and clay settle on top, sealing them off and trapping all that ancient water right where it was.
So, knowing this huge resource is down there is one thing. But with the world facing a pretty serious water crisis, the real question is, can we actually use any of it?
Let's talk about the price tag because, wow, a research expedition in 2025 called the Liftboat Robert actually managed to drill into one of these aquifers. That expedition alone cost $25 million. And the price of the water they actually managed to collect? You might want to sit down for this. $500 per liter.
Yeah, that price tag really shines a light on the huge hurdles we're facing. I mean, you're talking about building what are essentially offshore oil rigs, but for water. Super expensive. On top of that, a lot of this water is still a little bit salty, so it would need even more costly treatment before we could drink it. Bottom line, right now, it's just nowhere near cost competitive with other ways of getting fresh water. But, context is everything here. The UN predicts that by 2030, our global demand for fresh water is going to outstrip supply by a whopping 40%. The world is just getting thirstier and thirstier.
And that demand isn't just growing. It's being pushed by some new and pretty surprising things. Get this. By 2027, the data centers that power the AI boom are expected to use more than 4 times the amount of water as the entire country of Denmark, just to keep their servers cool. That changes the whole equation, doesn't it?
And so this all brings us to the final big question. As the world keeps getting thirstier, is technology going to catch up and make this hidden water an affordable lifeline for us? Or will this massive ocean of fresh water just stay locked away, an expensive, untouchable last resort, sitting right there, just beneath our feet?